Hi, everybody. Thank you for joining today's webinar focused on agriculture technologies. I just want to remind everybody, all attendees, that this webinar was primarily designed for participants in the Efficiency for Access Design Challenge, an initiative from the Efficiency for Access Coalition and Engineers Without Borders UK. If you have questions throughout the webinar, please ask them in the question box from the GoToWebinar window that you should see at the right of your screen. And we will address these questions at the end of this webinar during the Q&A session. I also want to remind everybody that this webinar will be recorded and made available for everybody on the Efficiency for Access website. So today our two speakers are Max Garnick and Carr. Thank you to both of you. So Max is a product manager for SunCulture, a Kenyan-based agtech company that was basically the first company to commercialize solar-powered irrigation in Africa. Max joined SunCulture 1 year ago after completing a mechanical engineering degree in Boston, after completing a number of tech-related internships, including a 6-month placement in Tanzania at Sikibora, a solar home system company. Matt is a renewable energy technical and market access specialist. He's worked at the forefront of energy access throughout the Pacific, Asia, and Africa with solar startups, international power companies, multilateral donors, and NGOs. As CEO of Agsol and living in Nairobi, Matt's role is to lead business operations, drive sales, and develop and foster great partnerships for his company that he will talk about, that is producing milling devices. Thanks to both of you, and Max, the floor is yours.
Good afternoon, everyone. My name is Max Garnick. As you just heard from Theo, I'm a product manager for SunCulture, working mainly on our core hardware products. So I'm happy to be a part of this webinar on agriculture technology and generally just to be involved in the Efficiency for Access Design Challenge. There's considerable progress that can be made in optimizing and increasing the efficiency of DC appliances for the off-grid energy sector. And I'm excited to work with dedicated, talented students to collectively make impact in the space. So at SunCulture, our vision is to build a world where people take control of their environments in rewarding, sustainable ways. We strive to do that by developing and commercializing life-changing technology that solves the biggest daily challenges for the world's 570 million smallholder farming households. Next slide, please. So today, Sub-Saharan Africa annually imports $35 billion of food. Due to rapid growth in population, demand for food on the African continent will continue to rise, and subsequently more and more food will need to be imported. The World Bank projects this number to increase to $110 billion by 2025. The significant driver for the need to import this food is because 96% of Africa's smallholder farmers rely on rain-fed agriculture. Now, what challenges come with dependence on rain-fed agriculture? Well, first, farmers are left no choice but to grow low-value crops. This is because rainwater is only sufficient to grow staple crops like maize and potatoes. Second, rain dependence results in lower crop yields. Africa's agricultural productivity is 50% lower than the world average due to rainwater dependence. Third, it results in limited growing seasons. Whereas a growing cycle for cabbage may be only 3 to 4 months, if a smallholder farmer is dependent on rain and there are only 3 or so month rainy seasons, the farmer will only be able to harvest twice per year. That is if they're lucky and the rains are good. As a result, smallholder farmers are trapped at the bottom of the productivity ladder. Smallholders make only $600 to $1,000 per year and are always just one bad harvest away from financial insecurity. They are unable to invest in their farms or in their families' futures. Next slide, please. Irrigation is the first step up the productivity ladder and is key to closing the yield gap. It increases yields by 2 to 5 times. While the entire agricultural value chain is important to truly solve the problem, access to water and irrigation are the first and most crucial step to increasing smallholder farm productivity, and income. Next slide, please. Irrigation is a $65 billion opportunity in Africa, and new technologies can channel the continent's existing resources into unlocking agricultural productivity. There's enough groundwater in Africa to expand irrigation by 20 times across the continent, and in 13 countries, the opportunity exists to expand by 120 times. Sunshine is abundant, and paired with falling costs of solar panels and lithium batteries, clean energy is becoming increasingly affordable and viable to power irrigation systems. Mobile penetration on the continent and mobile money solutions streamline payments and customer communication while simultaneously introducing the potential for data-driven precision agriculture. Lastly, Africa has 65% of the world's unused arable land. Irrigation will enable more of this land to be cultivated and will increase the productivity of land already under use for agriculture. Next slide, please. At SunCulture, we are tackling the irrigation gap head-on. Our flagship solar water pumping system, which we call the Rainmaker 2 with Climate Smart Battery, is an IoT-enabled irrigation system which has the ability to tap into groundwater as deep as 70 meters and with a flow up to 3,000 liters per hour. The system has been designed to irrigate up to 2 acres and is used by customers to pump water from a well, borehole, or river for agriculture, domestic use, and for livestock. The system is capable of up to 500 watts of consistent power output with a 24-volt DC output for the solar water pump and high-power appliances, 4 12-volt DC jacks to power the 4 LEDs that come with the system and/or the 32-inch TV we offer as an add-on, and 2 5-volt USB ports for phone charging. It's sold as a kit, which is inclusive of 100 meters of HDPE pipe to route water throughout the farm, 4 sprinklers for irrigation, a box of various PE fittings and valves, installation by a SunCulture field technician, and a 3-year warranty on all components. We sell this system for just under $1,000 through our direct sales network in Kenya and through distributors primarily in East Africa. And we also offer pay-as-you-grow financing to our customers on plans ranging from 12 to 30 months, allowing our customers to pay just $1 a day for the system. There are a number of plug-and-play upgrades we offer to our customers to continue climbing the productivity ladder, such as a drip irrigation to increase the efficiency of water used by about 35%, a TV with preloaded locally produced agricultural training content, DC pressure cookers, and likely in 2020, egg incubators and agri-processing machinery. We are also, of course, able to monitor the Climate Smart Energy System remotely through our IoT hub run on Microsoft Azure, through which we can ensure customers are using their energy efficiently. We run anomaly detection algorithms built into Azure on the battery, the pump output, and the solar panel input streams, which enable predictive and preventative maintenance for all of our customers. Next slide, please. At the beginning of October, so just about 2 weeks ago, we launched a new batteryless solar water pump controller called Climate Smart Direct, which we also pair with the Rainmaker 2 pumps. This system is capable of pumping water from as deep as 30 meters and with a flow rate of up to 2,800 liters per hour. Both Climate Smart Direct and Climate Smart Battery use MPPT conversion for optimal charging and power output, and Climate Smart Direct includes a proprietary brushless DC motor controller to regulate the RPM and flow rate of the Rainmaker 2 water pumps. The addition of the Climate Smart Direct module with MPPT and BLDC controller means that while the flow rate fluctuates based on the input power from the panels, the cumulative output of the system is over 2 times that of a direct panel to pump connection. This power system has a maximum output of 540 watts and also has pay-as-you-grow integration with remote monitoring through GSM and Sigfox. We sell this system inclusive of pipe, fittings, installation, and a 3-year warranty for just under $500. And again, we offer financing anywhere from 12 to 18 months, allowing customers to pay just 75 cents per day for this system. This system is solely for irrigation, so there are no lights, no phone charging, and no add-ons. But beginning in early 2020, Climate Smart Direct customers will be able to upgrade to Climate Smart Battery and continue up the productivity ladder from there. Next slide, please. So as a result of installing one of our Rainmaker 2 solar water pump offerings, our customers increase their incomes from their farms by about 5 to 10 times. 2 to 5 time yield increase and harvest security, the ability to shift towards cash crops like kale, tomatoes, and cabbage as a result of an abundant water supply, time savings of up to 17 hours per week from manually fetching water by the bucket method, 1.5 to 2 times increase in milk production from healthy livestock, an expansion of land under cultivation, and access to clean energy as opposed to kerosene all lead to both higher income and a better overall quality of life. Next slide, please. So let's look at what the acquisition of our systems means for one of our actual customers. David Kirubi Mutuga is a 43-year-old farmer based near Eldoret town in Kenya. He owns 3 acres of land and 1 cow, grows cabbages and potatoes, and started using a Rainmaker 2 with Climate Smart battery 7 months ago after switching from a diesel-powered water pump. From the Rainmaker 2, he now gets around 12,000 liters of water per day. David has now expanded his cultivated land from 1 to 3 acres and has increased his cabbage and potato production because he's now able to grow during the dry season and harvest when prices are 10 times higher due to shortages in the market. David has more income from selling increased produce at higher prices and from increased milk production from his cow. And he is saving money because he no longer needs to spend $5 per week to power his diesel generator to power his old pump. From his increased income, he's able to reinvest in his farm to continue increasing his agricultural productivity. He is planning to buy more cows to start making yogurt to sell, and he is able to send his boys to boarding school. Next slide, please. So scaling up access to irrigation has far-reaching effects towards promoting inclusive, sustainable development in Africa, with the potential to increase food security, lift millions out of poverty, and to fuel economic growth. Despite having most of the world's arable land, Africa is projected to spend, as I said earlier, $110 billion per year on importing food by 2025. Increasing agricultural productivity will empower Africa to feed itself. There's $150 billion in unmet annual demand for agricultural finance in Africa. De-risking farming through irrigation enables farmers to tap into the financing and markets that will keep them climbing up the productivity ladder. Lastly, agriculture employs more than half of the population in Africa and comprises 15% of the continent's GDP. Irrigation expansion in sub-Saharan Africa could generate up to $22 billion per year. Next slide, please. As you saw earlier in my presentation, the agricultural value chain is expansive, and irrigation is only the first step on the productivity ladder. Through continuous innovation, at SunCulture, we will accompany our customers as they progress up the productivity ladder, and we'll do this through technology development, providing access to data and tailored advice to our customers to boost productivity, continuing to provide financing through risk models that unlock further lending, and through dedicated customer care. Next slide, please. Lastly, as I believe many of you are more on the technical or engineering side, thanks to the 500-watt output capacity of our Climate Smart battery solar energy system, there are a number of personal and productive use appliances we feel we are in a good position to develop and offer our customers to continually increase their incomes and quality of life. So you can see here some of the appliances we would love to have you explore as a part of the Efficiency for Access Design Challenge. Next slide, please. All right, that's it from me. So thank you for the time. I look forward to continuing with the design challenge.
Thanks, Max, and do stay on the line for the Q&A session at the end. We'll do both at the same time. So we will now leave the floor to Matt. If you're willing to unmute yourself.
Thanks, Taya. Are you hearing me okay?
Yeah, I think it's good.
Okay, great, thanks. Hi everyone, thanks for joining the webinar, and thanks to Efficiency for Access for hosting it. Yeah, my name is Matt Carr, I'm the CEO and founder of Agsol. Agsol is a company that specializes in designing and manufacturing solar-powered agro-processing machines. We built out of a company from Papua New Guinea, where we started a few years ago, and we moved to Kenya middle of last year. So we're still early in our. We're still an early stage company, and we're dedicated to solving this tricky problem around energy access and using agricultural appliances to drive that. Next slide, please. So as I'm sure you're all aware, there's about 1 billion people without access to electricity, and most of those people are smallholder farmers that depend on agriculture for their livelihood. So this, as a starting point, represents a huge opportunity in driving energy access, and it also highlights that the most important technologies that will drive energy access are those that improve value in agriculture and along agricultural value chains. So similar to kind of what Max was talking about there, there's a number of energy steps along the agricultural value chain, from irrigation to ground preparation to harvesting and agro-processing. Next slide, please. The opportunity for agro-processing is because with the current technology, renewable energy technologies, stationary energy applications are the most relevant in and along agricultural value chains. And particularly for milling staple foods that off-grid farmers depend on, milling represents creates a lot of hardship and challenges for people. So the options for people to mill their food is essentially what you see on the screen, going from hand processing, which is laborious and tedious, to stepping up to a diesel mill. And diesel mills in East Africa typically start at around the 10 horsepower mark. So you go from this very kind of low productivity kind of activity in hand milling up to this large machine, which is really designed to provide milling services for several hundred households. So there's a big gap in the market and in what technologies are available to these people. The hardship that this creates is particularly, it becomes a burden of women who are invariably tasked with milling. And across Africa, women are spending about 30 billion hours each year in performing processing. So the next slide, please. So the issue, just to highlight those issues with diesel mills, is that they're the standard technology throughout off-grid Africa, and even the smallest diesel mills are oversized for small communities, and hence they're not present and available in small communities. So what that means is that particularly women in small communities are spending up to an hour every day to access those milling services. Next slide, please. So Agsol's solution is to link a smaller and productive agro-processing mill with solar power. And the goal of that is for that mill to provide the income generating kind of base load for that solar system, which can then deliver a host of other livelihood and economic benefits. This is what Agsol's technology is trying to do is really mimic how a lot of, indeed most rural electrification has happened in the past, which is providing productive and income generating loads that then drive broader energy access. Our customers our target customers are village entrepreneurs who sell milling services for a fee, or small farmer cooperatives or groups. Presently out there, our competition is really diesel mills, and There's one other company, Solar Milling, who's also developed a solar milling solution, but their technology is twice the cost of ours. Next slide, please. Agsol is initially targeting the maize value chain, or that maize is the most important staple food in East Africa, and creates the biggest burden around access to milling services. So in Kenya, for example, the maize harvest happens once a year, typically towards the end of the year, and a smallholder farmer will harvest all their maize. They'll shell it and then store their maize in their grain house, in their grain store, from which they take a portion of maize, every week or so to take to a mill for processing. Next slide, please. So Agsol's goal in developing this technology is to develop this more distributed network of milling services, and in doing so, reduce that burden and access to these essential services. So in the slide there above, that's a site we visited up in Trans Nzoia County, and within that area there was only, which is about 10 kilometers across, there was only one diesel mill serving that whole community. So people living 5 kilometers to 10 kilometers away from that mill are experiencing serious hardship in accessing those services. Next slide, please. So this slide just shows a little bit of modeling on the pricing of Agsol's technology compared to a diesel mill. This is modeled for a small community of about 80 households. And what it shows is that like with all renewable technologies, the upfront cost is initially higher than that of a diesel mill, but the payback period over time is significantly shorter. This also kind of opens up as I've talked about, the opportunity for that mill owner to sell other energy services and from other business activities. Next slide, please. Agsol's just starting out on our journey, but these are our goals for the 5 years ahead. This year we are putting 70 mills into market in Kenya and in Uganda, Tanzania, and aiming for another 500 mills next year, and then growing quite rapidly after that. So our 5-year goal is to see getting to 30,000 mill sales per year, and saving 170 million hours of women's time annually. Next slide, please. Yeah, so just in closing, I'd just like to say thank you to Energy Efficiency for Access. Efficiency for Access is supporting us in an R&D project presently, where we're developing a smaller little micro mill. In that product development, we're working with customized brushless DC motors, direct drive motors, and already in that R&D work, we're seeing a mill efficiency increase of 4 times what other small mills are available to do. So we think that's really exciting. We're really happy to be working with Efficiency for Access, and likewise with partners like SunCulture and other stakeholders in the space to drive energy access from productive agricultural machines. Thanks.
Thank you, Matt, and we're also very happy to work with you. So we're now going to move to the Q&A session. Thanks to both of you for your insightful presentations. So we have a first question from Ulysses, who is asking about underground water that is often contaminated. So that question is more for you, Max. Is there any filtering module we can add to improve pH and salinity without big energy and water losses?
Yeah, absolutely. This is well recognized. It's definitely one of the issues that's faced by submersible water pumps in particular, as opposed to surface pumps. Desalination units are still under heavy development, but extremely out of reach as far as pricing goes for a smallholder farmer. So there are some that have been developed at more of a village level, but they're still thousands and thousands of dollars. And require quite a bit of energy to run. So at this current time, yeah, we don't have a desalination method. Typically, our customers that have saline water sources will pump into elevated tanks and allow the water to sit overnight. And sometimes that can allow the salt to settle in the tank and separate from the water. But yeah, desalination is definitely one of the big issues faced by some of our customers. As for filtering out some of the sedimentation and some of the other minerals that might be in the water, when we, for example, install drip irrigation kits, they typically have mesh filters in line with the pump. So this can filter out much of any larger sediment.
Thank you. Another question for you, Matt. So obviously Agsol went for maize milling. So my question would be double. First, why did you go for maize? Was it a consideration of specificities within Kenya? And second, are there big challenges with changing crops and having a milling device for cassava or something else?
Yeah, that's a really good question. We developed or targeting a hammer mill because maize is the most important staple food in East Africa. In rural populations, people, it's generally a breakfast, lunch, and dinner meal, and so we brilliantly or courageously or crazily we chose maize because if we can make the technology work for maize, then and the business case work for maize, then it proves it represents a really scalable and important solution. The other here in Kenya, like I was saying before, they typically harvest once annually and then mill fairly consistently throughout the year. And that consistent milling requirement is really important as far as getting the utilization and payback on the solar system. In Papua New Guinea, when we started out, we sold more rice mills than anything else because it was the nature of the demand in Papua New Guinea. But what you see around rice, for example, is there's typically 2 harvests per year, and then all the rice needs to be milled very, very close to harvest. So with a solar rice milling solution, the mill is only getting used for about 4 months during the year, and then it's sitting idle, and therefore the solar system that the customers invested in is not being utilized. Interestingly, also across the border here, you step across to Uganda, and there's quite a different seasonal harvest cycle for maize. And coming back to the question around cassava, what you see in Uganda, for example, is that there's 3 months of milling maize, then 3 months of milling cassava, and then 3 months maize and 3 months cassava. So the mill that we've developed is a multi-feedstock mill. So it can, although we're targeting specifically maize, it can also process cassava, it can also process sorghum and millet, which are other important staples in the region. So that ability for the mill to process other staple foods and to keep that high utilization rate up onto the system is really key, and that's why we've concentrated on the hammer mill.
Thank you very much for the answer. We got another question from Silvio Oberi, one at a time. The question is about the high initial cost of solar home systems and standalone systems, which can be challenging, especially for small income earners, such as smallholder farmers. So the question is, how do you intend to support them to at least have a solar home system, or what kind of, how do you facilitate and how do you make your product accessible for these small income earners? And that's a question for both of you.
Okay, well, I can start. So the primary way that we make the systems accessible is through credit and through financing. So we directly finance our customers because you're absolutely correct. A $500 or $1,000 expenditure is there's hardly any market for a product that expensive. We would probably, our cash sales are somewhere around 5% of our total sales. So the financing aspect is critical. And while we explore ways to ensure that the deposit on a system is as low as possible, we do need to ensure that the customers are committed to the product. And in order to do that, we have to make sure that the deposit is somewhat substantial. So, for example, the deposit on our system that has no battery pack is only for solar water pumping. That deposit is around $75. And then the deposit for Climate Smart battery with a solar water pump, so that's more of a solar home system with a water pump, that deposit is $85. But yeah, through financing, we can make the systems much more accessible.
Thank you, Matt.
Yeah, from our side, we don't have the financing piece in place or the PAYGO piece in place yet. It's definitely something we are exploring and developing. I suppose for us, there's hundreds of thousands of diesel mills throughout the region, and small business owners buy these diesel mills and run them as a business. And a diesel mill costs about $1,600. So there's already the market. It shows us that small business owners are already prepared and have the means to raise capital to invest in a income generating asset like a mill. But yeah, certainly for us, we definitely see the PAYGO piece as a really important part of our future product development.
Thank you very much. Another question from William Brandt about power supply. Obviously, both of you are coming from companies that went for the standalone option, but the question is, what are your views on standalone systems versus mini grids for agriculture or food value chain technologies? Which one makes most sense? And that's assuming you looked into the two options. Maybe Matt, if you want to start.
Yeah, certainly for us, there's no silver bullet to energy access. Certainly, mini grids have their role to play, and yeah, we absolutely offer a mill in an AC format that can be run on grid. Typically grids by default, mini grids by default are built in areas where there's a higher density population, and so that works quite well for a larger milling system. Grids are serving, say, 200 to a few hundred connections, could certainly benefit from a more efficient milling solution. And yeah, we're working with a couple of mini grid partners here in Kenya to test out and trial out a more efficient milling solution. Again, the problem with the current electric mills typically available in the market here, they've been designed to match a diesel engine, and cheap and reliable diesel engines only start at around the 10 horsepower mark. So you match that with an electric motor, and you're looking at a 7.5 kilowatt mill. And the mini grids, like particularly the small mini grids, really don't like a load like that. Represents a really big load. There's a lot of inrush current when those machines are turned on, and it'll trip out the protection gear on most mini grids. So so we offer a mill with kind of soft starter options. It comes with a 2.2 kilowatt motor. So absolutely, that's an important piece of the puzzle. But mini grids aren't going to serve all of off-grid Africa, and that's kind of part of the big problem we're trying to solve is this access to essential services, and freeing up particularly women's time to be used more productively. So if in recognizing that, there needs to be smaller milling solutions that make sense for smaller communities, and that's a big part of the reason where we're developing these kind of more smaller mills and this micro mill that we have in development at the moment.
Yeah, to be honest, from my side, I don't have a whole lot to add. I think Matt hit the nail on the head. I think, like he said, there's no silver bullet. There are lots of solutions to the energy access problem. We do offer larger installations with solar water pumps that are grid tied, or can be added to a mini grid. But our primary customer base is that off-grid rural farmer who has no access to electricity at all, and they tend to be a bit more rural in areas that aren't so densely populated. So we definitely feel that for this market, standalone systems are the way to go.
Great, thank you very much. Another question that just came in is about more the technical specificities of your product, and that's coming from students that want to find how to improve these existing designs, right? So the question is, are there any aspects of your products you're looking at improving? In other words, what are the specific parts of your products that are still challenges to increase efficiency or affordability of your products, for example?
Yeah, sure. Happy to jump in on that one. What we find or recognized early on in what we're doing is that standard milling technologies out there were never designed to be efficient. They're designed to either be run off a diesel engine or a grid, and in both circumstances, they're essentially an unlimited power supply. It's very easy to oversize a diesel engine to make up the around optimizing the mechanical function of the machine, and kind of like I was saying before, with this new micro mill we're developing, we're kind of seeing a 4 times efficiency gain compared to what a standard small mill can produce. So that's gains made by improved mechanical efficiency and also from the motor itself, and that's the piece of work that we're doing with E4A, working with like these customized super high speed, super efficient brushless DC motors. So that's a big that technology in itself, those brushless DC motors, is a big kind of opportunity to make efficiency gains. Where I suppose, milling is a very energy intensive process. You can kind of get your head around that by just imagining, getting a piece of popcorn in your fingers and trying to crush it, and you really have to hit that piece of popcorn very hard to shatter it into smaller particles and to produce flour. So it is an energy intensive process. One of our biggest challenges is around batteries at the moment. Battery tech still hasn't really caught up on well, at least on the cost side yet. We need to include batteries with our machine because we need to have a consistent power supply to the machine. I suppose that's something perhaps a bit unlike a water pump. If with a direct drive water pump, if a passing cloud reduces the sunlight going to the panels, and the pump can just reduce in flow rate. But a milling machine needs that constant power supply kept up to it. So we're exploring, at the moment our mill is designed to be a bolt-on to a standard solar technology. Standard solar technology is still lead acid batteries presently, but certainly with our micro mill that's in development, we're looking at going down the lithium ion road.
Yeah, I mean, to just agree with Matt, the focus area would be particularly on batteries. Panel prices have come down, efficiency has gone up for panels quite a bit in recent times, but batteries in particular are still quite expensive. And we've seen that with our climate smart battery system. It's quite expensive still. So to maximize usage of the system for productive use appliances with as little expenditure as possible on the panel, the power system, etc., we'd like to see some more development into battery efficiency. And then I guess mainly on our side, we're pretty happy with where we're at with the solar water pumps. But with pressure cookers, egg incubators, agri-processing, there's essentially no DC market for these products at all. There's a lot of, if you were to go over to China, say, you would find a lot of AC pressure cookers, a lot of AC egg incubators, but there's not a whole lot of development happening on the DC side. So it's not even really an efficiency issue. It's just that there's nothing that exists. We've been distributing DC pressure cookers as a part of a grant that we received, and there's literally one factory that we found anywhere in the world that produces DC pressure cookers. And egg incubators on that side, we found a few, but there's major issues with insulation, simple things that could really help with the efficiency and use less of the sacred battery power that's included in the systems.
Thank you very much. And I want to remind the students that talking about batteries, one of the tracks of the competition is power management, and Friday's webinar will be around it. So hopefully batteries will increase in efficiency and will have some progress thanks to this competition. One last question, and I think we'll close this webinar. It's for both of you, but mainly you, Matt, because you mentioned several times that milling was an activity often undergone by women. And so our question would be, how did you take that into account when designing your device?
Yeah, thanks, Theo. Yeah, invariably across the world and developing world, food preparation is still kind of the task predominantly to women. What we see kind of going out into market is the activity of hand milling, hand processing is so tedious that the women are prepared to walk 10 kilometers with a 20-kilogram bag of maize on their shoulder because they dislike the activity of hand milling so much. So that's a very big part of kind of the philosophy behind our mills and what they represent, and it's really around improving access to milling services by making a product that is viable in smaller communities. So instead of having these mills dotted around 5 kilometers from each other, developing a technology so whereby a much more distributed network of milling services are available, which ultimately will free up the time of women to do other more interesting or productive activities with their time.
Thank you, Max. I don't know if you have something to say about that.
Yeah, sure. I mean, from our side too, it's typically the women are actually the ones in the household who are lifting up water by hand using the bucket and pulley method. And this is really strenuous work. You could be lifting a bucket down 100 meters into the ground, getting only 80 to 100 liters per hour, which really isn't enough to irrigate even a small farm. or to have water for domestic use. So on the pump side of things, yeah, we're freeing up a lot of time, similar to Agsol, for women to spend time with kids, or continue to work on the farm and increase the productivity there, or to even have automated irrigation and go maybe venture into town and start working a job. And then on the pressure cooker side also, there's a lot of impact there for our female customers. So wood fuels, burning wood fuels in a home, like most of our customers do, to cook food is really detrimental to long-term health. And so the pressure cooker, being a DC electric pressure cooker, displaces all of the wood fuels. So that's both time spent by women walking hours and hours to go and collect firewood or charcoal, as well as the time spent to prepare the fire before cooking. And so, yeah, on that side of things, we definitely keep women in mind at the forefront when we're designing our products.
Thanks. Another question just came in, so we're probably gonna conclude on that one actually. Kind of the same kind of question. So we just talked about how to take into consideration gender equality when designing a product. The question is now, how do you take into consideration the use of local materials and maybe local assembly or local manufacturing when designing your products?
Yeah, I can start with this one. So we do a fair amount of local assembly here in Kenya. It's definitely something we take into account, and that we strive to, we would like to have everything manufactured in the country, but there are sort of a number of issues and inhibitions for doing that. I think the primary one would be related to the government. They don't make it particularly easy to set up a manufacturing plant here in Kenya, and to do so would increase the price of our goods to the customer at the end of the day. So much of our supply chain is, for the time being, in Asia, and that's simply to keep the cost of the system down for the end customer.
Yeah, similar for our sides. It just on the economics, it just makes way more sense, at least at this stage, for us to develop and source our technology out of China, where we have a base, and that's where the grunt work of our product development happens. Going into the future, and as the company grows, we would love to be able to support local business and the local economy here in Kenya with shifting some of that that manufacturing, or at least perhaps some of the assembly side of it across to here. But ultimately, if we want to have this scale at impact at scale, which I'm sure goes to the heart of SunCulture's kind of mission too. We need to be selling these technologies well beyond just Kenya or East Africa, and to do that efficiently, if we're going to sell products into Nigeria or to Burkina Faso or into India or wherever, having a single kind of single manufacturing hub and logistics hub is the most efficient and cost-effective approach. And as Max said, that if our costs in production go up, they ultimately have to get passed on to the consumer, and that's the last thing we want to do. So yeah, for now, China is where we have to do stuff.
Well, thanks to both of you for your answers, and thank you for your presentation. Thanks also to all attendees for following this webinar. We will meet again tomorrow, same time, for the refrigeration webinar with our industry partners from MCOPA and the University of Hohenheim, and we'll talk about fridges, an important field for appliances as well. Thanks, Max. Thanks, Matt. And have a good day, everybody.
Thanks, Ted. Thanks, everyone. Have a good day. Bye.